Jupiter, the largest planet in the solar system, is a gas giant that has captivated humanity for centuries. Its massive size, swirling storms, and dynamic atmosphere make it one of the most intriguing celestial bodies to study. Scientists have long been fascinated by its composition, magnetic field, and the numerous moons that orbit it. Jupiter's sheer scale is difficult to grasp. It is so massive that all the other planets in the solar system could fit inside it. With a diameter of about 139,820 kilometers, it is more than 11 times the size of Earth and has a mass that is more than 318 times that of our planet. Jupiter's immense gravity has shaped the architecture of the solar system, influencing the orbits of comets, asteroids, and even other planets. The formation of Jupiter dates back approximately 4.5 billion years, when the solar system was still in its infancy. Scientists believe that Jupiter was the first planet to form from the solar nebula, the swirling cloud of gas and dust that surrounded the young sun. Due to its location beyond the frost line, where volatile compounds such as water, methane, and ammonia could condense into solid ice, Jupiter rapidly accumulated mass. The planet's strong gravitational pull allowed it to attract enormous amounts of hydrogen and helium, the lightest and most abundant elements in the universe. This process of runaway accretion enabled Jupiter to grow into the behemoth we see today. Jupiter's atmosphere is a dynamic and ever-changing world of swirling clouds and ferocious storms. The planet's outer layers are composed primarily of hydrogen and helium, with trace amounts of methane, ammonia, water vapor, and other compounds. These elements interact in complex ways, creating the distinctive bands and zones that encircle the planet. The lighter-colored zones are regions of rising air, while the darker belts indicate areas of descending air. Powerful jet streams, driven by the planet's rapid rotation, separate these bands and create the stunning, striped appearance that defines Jupiter. One of Jupiter's most famous features is the Great Red Spot, a colossal storm that has raged for at least 350 years. This massive anticyclonic storm is larger than Earth and exhibits wind speeds that reach up to 432 kilometers per hour. Scientists are still studying the mechanisms that sustain the Great Red Spot, but it is believed to be fueled by deep atmospheric convection and Jupiter's internal heat. Recent observations suggest that the storm is shrinking, leading researchers to speculate about its future and whether it will eventually dissipate. Jupiter's magnetic field is the strongest of any planet in the solar system. Generated by the motion of metallic hydrogen within its deep interior, this powerful magnetic field extends millions of kilometers into space. The magnetosphere, the region dominated by Jupiter's magnetic influence, is so vast that it could easily encompass the Sun. Within this magnetosphere, charged particles are trapped and accelerated to high energies, creating intense radiation belts. These radiation belts pose a significant challenge for spacecraft that venture too close to the planet, as they can damage electronic instruments and pose risks to human explorers. The planet's interior remains a topic of scientific investigation, but current models suggest that Jupiter has a core composed of rock, metal, and hydrogen compounds. Surrounding this core is a vast region of metallic hydrogen, a unique state of matter that exists under extreme pressure. This metallic hydrogen layer is responsible for Jupiter's powerful magnetic field. Above this layer, the planet transitions into a thick envelope of molecular hydrogen and helium. Despite extensive study, the exact structure and composition of Jupiter's interior remain uncertain, and future missions will continue to probe the depths of this gas giant. Jupiter is home to an extensive system of moons, with at least 95 natural satellites identified to date. Among these, the four largest moons, known as the Galilean moons, stand out as some of the most fascinating objects in the solar system. Discovered by Galileo Galilei in 1610, these moons, Io, Europa, Ganymede, and Callisto, each have unique characteristics that make them prime targets for exploration. Io, the most volcanically active body in the solar system, is constantly reshaped by its many erupting volcanoes. The intense tidal forces exerted by Jupiter and the other Galilean moons generate enormous amounts of heat within Io, driving its extreme geological activity. The surface of Io is covered in lava flows, sulfur deposits, and volcanic calderas, creating a hellish landscape unlike anything else in the solar system. Europa, another of Jupiter's major moons, has captured the attention of scientists due to its potential to harbor life. Beneath its icy crust lies a vast subsurface ocean, kept warm by tidal heating. This hidden ocean may contain more than twice the amount of water found on Earth, raising the possibility that microbial life could exist in its depths. Future missions, such as NASA's Europa Clipper, aim to explore this intriguing moon in greater detail and assess its habitability. Ganymede, the largest moon in the solar system, is even bigger than Mercury. It possesses its own magnetic field, a rare feature for a moon, and exhibits a complex geological history marked by ridges, valleys, and impact craters. Scientists believe that Ganymede may also harbor a subsurface ocean, adding to the growing list of icy worlds that could potentially support life. Callisto, the outermost of the Galilean moons, is a heavily cratered world that has remained geologically inactive for billions of years. Despite its apparent lack of activity, Callisto is of great interest due to its ancient surface, which preserves a record of impacts dating back to the early solar system. Like Europa and Ganymede, Callisto is also thought to have an internal ocean, further expanding the possibilities for habitable environments within the Jovian system. Beyond the Galilean moons, Jupiter's extensive moon system includes a diverse array of smaller satellites, many of which are thought to be captured asteroids or remnants of larger bodies that were shattered by impacts. These moons vary widely in size, composition, and orbit, contributing to the complex and dynamic environment surrounding the gas giant. Jupiter also possesses a faint but fascinating ring system, composed primarily of dust particles. Unlike Saturn's bright and icy rings, Jupiter's rings are dark and difficult to observe. They are believed to originate from material ejected by its small inner moons due to micrometeorite impacts. While not as visually striking as those of Saturn, Jupiter's rings provide valuable insights into the processes that shape planetary ring systems throughout the solar system. Exploration of Jupiter has been carried out by several robotic spacecraft, beginning with the Pioneer and Voyager missions in the 1970s. These early missions provided the first close-up images of Jupiter and its moons, revolutionizing our understanding of the giant planet. Later missions, such as Galileo, Juno, and the upcoming JUICE, Jupiter Icy Moons Explorer, have continued to reveal new discoveries about Jupiter's atmosphere, magnetic field, and moons. Each new mission brings us closer to unlocking the secrets of this colossal world. Jupiter's influence extends far beyond its immediate surroundings. As a gravitational powerhouse, it has played a significant role in shaping the evolution of the solar system. It has acted as both a protector and a disruptor, deflecting some comets and asteroids away from the inner solar system, while also occasionally redirecting others toward Earth. Some researchers believe that Jupiter's gravitational interactions may have been instrumental in the formation of our own planet and the development of life on Earth. Despite all that we have learned, Jupiter remains a world of mysteries. Its deep interior, complex weather systems, and enigmatic moons continue to challenge our understanding of planetary science. As future missions venture closer to this giant planet, we can expect even more astonishing discoveries that will reshape our knowledge of the solar system and our place within it.